Good morning, everyone. Today we will be learning about simplifying radicals and the relationships with exponents. Let's start. So first, before we move on to that, I'd like to review index laws as this will serve as a major part of the process when it comes to simplifying radicals. It'll definitely serve as the major focus for us. So yeah, let's start. And I want you to see their relationship. So okay, let's start. So index laws. The first index law states that if A, if we have the same number here and different various exponents, let's say 3 raised to 3 multiplied by the same, it has to be the same number. Okay, let's say 3 raised to 7. We can simply write that as 3 plus 7, or am plus n. Therefore, it will be 3 raised to 3 plus 7, which is 3 raised to 10. That's what the first index law states. Let's move on to the second one. So if we divide the same number with different exponents, we can actually subtract this. So the second law states that if we divide numbers with different exponents, we can write that as m minus n, right? So let's say we have 3. I'll use 3 again. 3 raised to 3 over 3 raised to 2. So that can simply be written as 3 raised to 3 minus 2, which is equal to 3 raised to 1, which is 3. Why? Because 3 raised to 3 is 27, right? 3 times 3 times 3. And then 3 raised to 2 is 9. And that would give you 3, which is why this law works. Okay. The next law is when a number with an exponent is inside a quantity sign and there is an exponent outside the quantity sign. Let's give an example. One example is, let's say 4 raised to 2. Yeah, 4 raised to 2. And then n is 2. Yes. So, if you encounter something like this, let's say in your entrance exams or your long quizzes, there's an easy way to solve this. And you just multiply the two exponents, which is 2 times 2. That would be 4 raised to 4. And that's what the third law states. If there's an exponent inside a quantity sign and an exponent outside, you can multiply it. And your answer would be 4 raised to 4, which would give you 64 times 4 times 4 times 4. That would probably give you 256. Yes, and if you want to verify it for yourself, 4 to the second power is 16. 16 squared is 256, which is why this law works. Next, we have the fourth law. And the fourth law basically states that if AB is inside a quantity sign that can be either two numbers and there's an exponent outside, we can substitute those two values with the exponent. So it'll become AM, I believe, and then BM. Yes, so we just substituted M on both of the values. An example would be, let's say 2. 2 and multiplied by 3 with an exponent of 13. 13, like that. So here we can just substitute the exponent to both of the values, which would give us 2 times 13 times, no, not times 13. 2 raised to 13 multiplied by 3 raised to 13. And that would give you the same answer as, well, doing it manually. Let's say you decide you can multiply this, and that would be 6, and you try to get the 13th power of 6. You'd still get the same answer as this. Yes, okay. Next, we have the fifth rule, or the fifth index law. So whenever you see something like this, it's the same thing as multiplication. We can substitute m on both of the values, so it become am over bm. Yes. Say, so like, it'll become like this, and let's say 8. Let's give an example. Let's say 4 raised to 2 over 4 raised to 1. Yes, and we can just use the second law to solve this. So that would be 4, 2 minus 1 equals 4, 1. And the answer is 4. So that's how you solve something like this. Once you substitute the exponent to both of the values, you can just apply the second law. Okay, so what happens if there's a negative on an exponent? How are we going to solve that? Well, if there's a negative, then we can just simply write that as a as 1 over a raised to m, right? Yes, because if there's a negative exponent, we always put that under, not over the fraction, meaning we always put it under, like in the denominator. Let's say we have 3 raised to negative 1. Well, 3 raised to negative 1 would technically just be 1 over 3. 1, but we don't really need to write 1. So yeah, that's basically what the sixth law is trying to tell us. Next, we have the final index law. And this law is when a number is raised to 0. So how do we solve it? Well, every time, this is very important, every time a number is raised to 0, it will always equal to 1, no matter what. No matter what, a number raised to 0 would always be 1. So it can be 3 raised to 0, 2 raised to 0, 1 raised to 0. Every time your value would be 1. Okay, that is basically the index laws, and this will be a very important lesson as we go along the way and try to solve radicals, because there's a relationship between these two. And stay tuned in the second part where I will showcase the computation for radicals and how this can be related to certain exponents. Thank you for listening.